Welcome back to our Introduction to Java series. This is part 4 of our series where we will be learning about conditionals. So I'm going to make a new package and call it part 4. And in part 4, I'm going to make a Java class called conditional examples. So new Java class, conditional examples. Conditionals are our true, false validation checks. And in this case, these are going to be really simple methods that we are working on, but you would be able to utilize these for more complex programs going forward. But understanding the simple portions will help you out with determining those issues. So conditional example, it's a new class. I'm adding it to my Git repo, which there is a link in the description for you to go to. So everything that we code in these videos will also be available on my GitHub. So we need to make the entry point for our Java program. That is, as you probably have now memorized, public static void main string args. And the first conditional example that we are going to do is to have you determine whether or not you knock on my door. So at the university I work at, my door is a nice glass door, so you can actually tell whether or not I'm in my office. The good news is I get no privacy, but that's okay. So I have a nice glass door and you can tell whether or not I'm in my office. So if I'm in my office and my door is closed, you should knock on my door. If I'm not in my office and my door is closed, there's no reason to knock on the door because I'm not there. And if I'm in my office and the door is open, most likely that's office hours, so you're welcome to just come right in and say, "Hi, Dr. Skiles, what's up?" So let's code that. So we're going to make a method that returns a Boolean that tells you whether or not you should knock on my door. So we're going to call this method knock on door. So that's public static. And the reason this is static is because our main method is going to be directly calling this method. And so all static methods can only directly call other methods if they are static. Static means they don't change their spot in memory. When we get further into the object-oriented world, that's when we'll stop making these static methods. So right now, public static Boolean, and then knock on door. And it's going to pass 2 parameters. As I mentioned before, one is whether or not I'm in my office. So that would be Boolean prof here, as in the office. And then the other one would be whether or not the door is closed. So Boolean, and we'll call this door open. So I'm going to put some comments right above this so that we don't lose track of what the end goal is. What we're saying is that when I am in my office and the door is open, you do not need to knock on the door. So knock on door. I'm in my office, so true. And the door is open, so true. Then the result should be false. And then the other example I'm saying is I'm in my office, but the door is closed. So knock on door. I'm in my office, but the door is closed. So we're passing false. Then this should return true. And then all other scenarios should really return false. So right here you can tell you have a little red squiggly. Let's zoom in a little so you can read it a little better. So there's a little red squiggly under here that's saying we're not returning a Boolean. We're missing our return statement. So we need to write our evaluators and return true or false. So if I'm in my office, right? So if prof here and the door is closed, you would knock on my door. So we need to say not open. So not is an exclamation point. So not door open. Then we can return true. Otherwise, in all other scenarios, you should not knock on my door. One, either the door is open and I'm in there, so I'm going to just say, hi, what's up? Or I'm not in my office, so you're knocking on the door to talk to the ghost in the university. So we're going to return false. So yes, you might be looking at this and saying, can't I simplify it? And yes, you can. But right now, we are going to test this version and then we'll work on simplifying the problem. So testing it. This returns true or false. We can just say system.out.println, and let's call the two scenarios that I wrote up here. Knock on door, true, true, and knock on door, true, false. So knock on door, true, comma, true. And then IntelliJ shows some annotations here. So prof here, colon, you don't need to type that. All you need to type is true, comma, space, true. Okay? That's IntelliJ putting the prof here and the door open. And then the other scenario we wrote was system.out.println. And we'll say knock on door, I'm in my office, but the door is closed. So true, false. Let's run this and make sure that we're getting the results back we expect. So right click, run, or Control Shift F10. Or whatever shortcut it is on Mac. So it builds, and first we return false, which is what we expected, and then true. So don't knock on the door, knock on the door. So can we simplify this? And the answer is yes. Here we're saying if the prof is here and the door is not open, return true. So what we're saying here is if this is true, return true. Otherwise, this was false, so return false. So we can actually make this all one return statement. So you can say if, and we can copy this entire if statement here. So we can make this one return, and we can just say return prof here and door not open. Now we've made a test, and it should be equivalent to what we wrote earlier, but we don't just assume that it works. So let's rerun our code again and make sure that we still get false and true. Right click, run. And there's our answer, false and true. This is really important whenever you make a change to your code, no matter how insignificant it seems. Don't push it straight to prod. You test it. Okay? And you should test it. Then your QA tests it, and then it goes out to prod, and then your customers test it like all good programmers actually do, right? No. Test your code. Always test your code. Your code is what you own, and it represents you. Okay? So now let's learn about something called ternary. Okay? Ternary conditions. So I'm saying false or true, but maybe I really want to say knock, don't knock, right? And we're doing the statement here where it says knock on door, and we're returning either true or false. So this result here returns true or false. So I can put a little question mark, and this says if knock on door is true, then we're going to outprint the string knock. Otherwise, output the string don't knock. And then we can do the exact same, copy this line of code for our line here. So if we run this, now we should get don't knock and knock. So right click, run, don't knock, knock. This is called a ternary operator. So it takes in something that gets evaluated as either a true or false statement, a Boolean, and then saying whether or not it's true or false gives you those answers. So this is, if it's true, we do knock. If it's false, don't knock. So on the left side of your colon, it's knock. On the right side, don't knock. True, false. Okay, so now we've learned just how to do a simple conditional example and simplify our program to be one return statement. You've also learned about ternary expressions. So let's work on another conditional project. Conditional function. Let's compare if two numbers are equal. So let's make a new method. I'm going to call this public static, and it's going to also return a Boolean. And we'll say R equal. Actually, let's make it a little bit better. Integers are equal. Now, granted, you really wouldn't need to write a method for this, but we're going to have a method for this just to illustrate it. So in this case, we're going to take in two integers, and we're going to say whether or not the two numbers that we get in are equal. So int x and int y. Those are our parameters. So if x equals, so equal y. This is how we check if two numbers are equal to each other. If you wrote x equals y, this isn't valid. This is actually setting x equal to the value of y. And we're inside an if statement, so we need to return true or false. So equal is doing our comparison of our two integers. In this case, if x equal y, we return true. Otherwise, we return false. Can we simplify this just like we simplified knock on door? And yes, we can, right? Because if x equals y, that means they're both equal to each other. This saying, if it's true, return true. Otherwise, return false. So we can make this one statement. So I'm going to remove this, and it's going to be return x equal y. So let's test this code. We're going to do system.out.println, and we're going to go integers are equal, and we're going to pass 15 and 15. These are equal. So we expect true to get outprinted. I'm going to leave a comment right here that says true. And then our another line will be system.out.println. We'll do integers are equal, and we'll pass 10 and 11, which are not equal. So we should get false. Let's test our code. So right click, run. In our first scenario here, with our knocks don't knock, go first, and then we get true and false. So now you know how to compare numbers, actually primitive types to be exact. These could be doubles or booleans, all that worked exactly the same way. So the last example that we're going to do is to determine whether or not a number is even. So if a number is even, we're going to return true. Otherwise, we are going to return false. So we'll make a new method, and we'll call this public static, and it's going to return a Boolean again. And we'll call this number is even. And we'll pass in one parameter, and that's our number. So int number. So in Java and other programming languages, there's an operator called the module. And modulo determines by division whether or not there's a remainder. It gives the remainder. So if you had the number 15 and you did modulo 2, then what would actually be returned is 1, because 15 divided by 2 has a remainder of 1. If you did 14 divided by 2, the remainder is 0. So, yep, there's a little bit of math sprinkled in everything. So, if number mod 2 equal 0. Remember, back to our integers are equal. We have to do a comparator of the equal sign. Then we return true. Otherwise, we return false. Or we could get rid of our else sign and just do return false. Or we can simplify this even more, correct? So as we reviewed in these last two statements here, we can do if, because if number mod 2 equal 0, that's basically saying if true, return true. So we can do if number, so now we can do return number module 2 equal 0. Let's test this, okay? So going back down to our main method, system dot out dot print line, and we'll say number is even. So the first example we're going to pass is 15, so 15. And that should be false, right? So going back to our old outprints here, we have don't knock, knock, true, false. And the next answer we determine is false. And then system dot out dot print line number is even 14, which should return true. So let's run our code and make sure it works. We got false and true. So it works. Now, every single one of these examples, I was able to turn into one line, mostly because we're returning a Boolean here. If we were doing something like outprinting, so we're returning nothing, this would change the problem a little bit. So let's make a number is even that returns nothing, so it returns a void. So let's do a public static void, and I'm going to call this number is even, and I'm going to call it v2, because otherwise they're going to conflict with each other. So number is even, v2, pass int number. So in this case, when the number is even, I want to say it's even or it's odd, okay? So if, and we did our check before, this number %2 equals 0, then system dot out dot print line number is even. So in this case, we are not returning. So when we return, we break out of our method. In this case, we're doing an if statement. We go to our system.out print line, and then it goes to the next line. So therefore, to ensure that we don't do a system.out print number is odd, so we end up saying number is even, number is odd at the same time, we need to have an else. So else, we're going to copy this line. So system.out print line number is odd. So what happens here is that we go into our if statement, and if we passed in 14, it goes 14 mod 2, and then that answer is 0, so we'll outprint number is even, and it will not go into this else statement. So it does not go into this code block and moves on and exits out of the method. Otherwise, if we passed in something like 15, this would be 15 mod 2, which would turn false, we would not go into this. We end up going to the else bracket and doing this work. Okay? So let's run this. So what I'm going to do is call number is even, version 2. And we're going to pass 14. And then number is even, version 2, and we're going to pass 15. So we should get number is even and then number is odd. Right click, run. Number is even, number is odd. So in this example for part 4, you've learned how to do if statements. You've learned how to work with conditionals, such as doing your booleans for passing them in and returning. You've learned how to compare numbers. You've learned how to also determine remainders. And you've learned how to outprint instead of just returning a boolean. You've also learned about ternary operators. So congratulations, you are now, yet again, another step further into being a master of Java.